So that is all not defectives right there. That's the only way that they're all n's. So there's one way that can happen. So the probability of this, well, the probability of not having defectives, so this one is 20% chance. So that means the other 80% of the time you'll have a battery or a light bulb that's not defective. Well, that's going to be 0.8 times 0.8 times 0.8 times 0.8 because the probabilities are independent of one another. We're told that in the problem. So this is really just 0.8 times 0.8 times 0.8 times 0.8, which is 0.8 to the fourth power. Okay, now I am going to change colors here, and now we'll keep track of the number of ways to get 1. So that means we have exactly one defective. All the others are n's. So we're looking for situations where there's only one d. So that's here. There's one. There is one here. And where else do we have one? We have one there. So it looks to be the case. Did we miss any? Let's go back real quick, do a quick sweep through because it's easy to miss them. We're again only looking for situations with 1D. It looks like those are the only ones. So actually we have one more right here. And so we have a total of 4 of those. Now, because they're in different orders, like this, the probability of this guy here would be 0.2 times 0.4 times 0.4 times 0.4, which is basically 0.2 times 0.4 to the third. Okay, well, that's going to be the same thing for this guy here, except he'll have a 0.4, 0.2, 0.4, 0.4, but it doesn't matter what order you multiply 0.2s and 0.4s in, these will all be the exact same probability. So we'll have 0.2 times 0.4 to the third power, and we have 1, 2, 3, 4. We'd have to add 4 of these together. So I'm just going to, instead of adding, I'm going to multiply by 4, because it's like saying, you know, you're going to give out $55 bills. Well, you could do 5 plus 5 plus 5 plus 5 50 times, or you could just do 50 times 5. So we're doing the same thing here. So that gives us all the situations where there's exactly 1. Now, I'm not going to actually write the probabilities in. We'll come back to that. I'm going to use the green color now and do all the 2's. So I have 2 there, I have 2 there, I have 2 there, I have 2 D's there, 2 D's there, and 2 D's there. So that's 1, 2, 3, 4, 5, 6, and I'm confident in that, that we captured them all. So same type of idea here. 2 D's, each D has a 20% chance. Each N, oh, I'm sorry, I think I used 40. I don't know why I used 40 here. I'm going to go back and update these. You're probably wondering, what's this crazy guy doing here? So these should be 0.8s, not 0.2s, 0.4, excuse me. So let's go back to the green. So this will be 0.2 squared times 0.8 squared. And same thing for all these guys. We'll just be multiplying 2.2s and 2.8s in different orders. But we've got 6 of them, so we'll do 6 times that. And we can move on to the next one. Now you might be noticing a pattern. If you look at these guys, notice that this is really to the first power, and this is to the third power. So we have 0.2 to the 1, 0.2 to the 2. Well, that happens to match up with these numbers here. You might say, but what about the first one? Well, if I wanted to kind of replicate this idea in the first one, I could probably write, well, how many times am I multiplying by 0.2? Well, I'm doing it 0 times. So there's never anything wrong with multiplying something by a value raised to the 0 power because x to the 0 is equal to 1. Any value, I probably shouldn't use x here, b to the 0 is equal to 1, provided that b is not equal to 0. So anything raised to the 0 power is 1. And, well, how many replicates of this did I have? Well, I only had one situation where they were all n's. So notice how there's a pattern here, except we don't see a pattern in the 1, 4, 6 so far. So I'm going to change colors again here, and we'll do the third, or situations where there are 3. 1, 2, 3, 4. So it looks like there are 4 of them, and then the only one remaining is where there are all 4 D's. So I just counted 4 of those. To have 3 D's means you have 20% times 20% times 20%, and you only have 180%. So notice that. Hey, these powers are adding up to 4 all the time. We have 1, 2, 3, 3, 2, 1. And